Alright, what is up, my Form 3? Okay, welcome back to our weekly class. Okay, this is May, third week of May. Okay, so apparently we are still gonna have our online class for at least another 4-5 weeks. Okay, so yay. Okay, so this week we are going into a new chapter, which is generation of electricity. Okay, chapter 6. Okay, we have finished chapter 5. Very simple, exo and endothermic. Okay, this week we will talk about electricity. Okay, you have already learned electricity in Form 2, but this part is more about how do you generate it, how do you send it to homes and factories and all. Okay, so let's look at how do we generate electricity at first. Okay, you have already learned this in Form 2. You have renewable and non-renewable source of energy. So what is renewable? Okay, that is continually never be deplete. Okay, it will never deplete. Okay, non-renewable means it will be depleted. Okay, so what are the examples? Okay, you have hydro, you have wave, okay, solar, tidal, okay, tidal or wave, okay, wind, biomass, geothermal. Okay, all these they have unlimited supply. Okay, like wind, it's not gonna run out. Okay, but for renewable, we have nuclear, and the other three we call it fossil fuel. Okay, coal, natural gas, and petroleum. Okay, unfortunately 80% is still relying on fossil fuel. Okay, this shows you that how inefficient renewable energy actually is. Okay, it's only 20%. Okay, sad to say that. That's why our pollution is such a big problem, because fossil fuel creates a lot of waste, okay, especially carbon dioxide. That's why global warming is very serious. Okay, so power stations in Malaysia, okay, all these you can just read through, okay, nothing much here. Okay, so okay, how do we generate electricity? Okay, the basic concept, let's look at the basic concept. Okay, excuse me. Okay, something that generate electricity, we call it a generator. Okay, I know you're expecting a very changi name. No, it's called a generator. Okay, so a generator has two parts. Number one, you need a magnet. Okay, you need a magnet. Okay, of course, north and south lah. Okay, you need a magnet, you need a wire. That's all. Okay, you need to move one thing and then make another thing stay there. Okay, you can move the wire and hold the magnet, or you can move the magnet and hold the wire. This will create electricity. Okay, so this is basically how electricity is generated. So when the crank, okay, means a turn, crank is the turn. When the crank of generator is turned, induced current is produced. Okay, so this current will light up LED. Okay, so who discovers this? Okay, we have to thank someone. He's the father of electricity. We call him Michael Faraday. Without him, there will not be electricity today. Okay, he is the one who discovered that if I have a magnetic field and then I have a conductor moving through a magnetic field, I can create electricity. I'm changing kinetic energy into electrical energy. Okay, so amazing, isn't it? Okay, so just use any magnet and move any conductor through it, you will create electricity. This is what Michael Faraday says. Okay, so basically all modes of generating electricity, okay, just now we have renewable and non-renewable, the concept is the same. I need to use kinetic energy and change it into electrical energy. We'll talk about this later. Okay, so like I said just now, you can either move the wire or you can move the magnet. Okay, as long as one stays still, the other move, you have one cutting through another, okay, the motion cutting through another, then you will have electricity. Okay, so you stay the magnet, move the conductor, or stay the conductor, move the magnet, you will create electricity. Okay, so this is what you call a solenoid. Solenoid basically is a coil of conductor. Okay, conductor is like that, one straight line. If you coil them, it's called a solenoid. Okay, so this one, it moves the wire. Can you see the wire is moving up and down, and then you can see the meter move, means there is electricity. Okay, and then for the magnet one, now I'm moving the magnet up and down, and then there's electricity. Okay, doesn't matter, you just have to move one, make one stay, then you create electricity. Okay, so basically that is generator. Okay, so can you see here, I turn the conductor and then the magnet stays. Okay, I create electricity. Okay, so let's look at power station. Okay, basically power station is a big generator. Okay, it's a stupidly big generator. How big? It can be 5 floors high. Okay, but the concept is the same. Okay, a small generator like this and as big as 3 stories, it's the same. I'm turning conductor or I'm turning magnet. Okay, so concept is the same. Okay, so just now we said that we need to convert kinetic to electric. Okay, all power station works the same way. Okay, so how do we create kinetic energy? Okay, let's look at thermal. Okay, thermal means I use fuel like petrol or coal or natural gas to generate electricity. So basically, how does it work? Okay, fuel is here. Fuel will burn water. Okay, I boil water. Okay, when water is boiled, it changes into steam. Okay, it changes into steam. So steam has high kinetic energy because steam is very hot. Steam can move very quickly. And then I'm here to spin the turbine. Okay, what is turbine? Turbine is basically like a fan. Okay, just now we call it a crank. Can you see? Okay, a crank. Crank we use hand. Turbine, this one we use machine. It's basically it's a big crank. So we just turn the turbine. And then the turbine is connected to a generator. Can you see? Same concept. I'm spinning the magnet or I'm spinning the conductor. Okay, I'm using steam to spin it. Okay, in thermal. Okay, so I generate electricity. So after the steam slows down, I will go back into the fuel. Okay, go back to the fuel to be reheated again. So I'm changing. Okay, what you need to memorize here is the chemical change. It's not really memorized. It's common sense. So fuel has chemical energy. So when I burn chemical energy, it changes into heat energy. Okay, heat energy produces steam. So steam, it has kinetic energy. Kinetic will change to electrical energy. Okay, common sense. All right. So hydroelectric, same thing, but this time it has no burning or whatever. Straight away you have kinetic energy. You have GPE. Okay, potential energy, gravitational potential energy. You learned this last year. It will change into kinetic, and then it will change into electrical. Okay, so same thing. I'm spinning the turbine, which will spin the generator. Same concept. Okay, like I said, all generator works the same way. I just have to spin the turbine. There are millions of ways to spin the turbine. Okay, so you can use fuel. Okay, or here you can use hydropower. Okay, they say hydropower is one of the cleanest energy. So why are we still not using it extensively everywhere? Number one, you can only use it in countries that has a lot of river and it has no freezing winter. Okay, which means a lot of northern countries, they cannot use this. Okay, and building a hydroelectric dam is very expensive. Okay, and also it is not very good for the environment. Okay, you will flood a lot of forest areas and then you will make the downstream dry. A lot of forest is gonna be dead. Okay, that's why, is it clean? Depends on how you look at it. Okay, all kinds of electricity generation has some sort of impact on the environment. Okay, see whether it's how serious it is. Okay, so next, okay, let's look at nuclear. Okay, nuclear works the same as thermal. Okay, I'm heating water into steam and then the steam will spin the turbine. Okay, so what's the difference? Okay, so I have nuclear energy, heat energy, kinetic, and electrical. So almost the same. Okay, so what makes nuclear so... Okay, nuclear is the most controversial energy. Some say it's the cleanest. Some hates nuclear. Okay, let's talk about nuclear. Okay, uranium. Not every country has it. Okay, uranium is at least a few hundred times stronger than fossil fuel. Okay, which means if you burn uranium, it's gonna create the same mass, 1 kilo of uranium and 1 kilo of petrol. 1 kilo of uranium is gonna give you much more energy. Okay, so I've even heard that if you use nuclear to run your car, you don't need to pump petrol for a few years. Wow, imagine that. But here's the thing, after burning the uranium, the leftover, the waste, we don't know where to throw it. We still don't know where to throw it. Okay, that's a very good question. And nuclear power station is like a nuclear bomb. Anything goes wrong, that is a serious disaster, like the Fukushima power plant in Japan. Okay, the Fukushima Daiichi power plant. You can go and search in Google. Okay, that's why nuclear has such a bad reputation. But here's the thing about nuclear: burning fossil fuel creates a lot of carbon dioxide. Okay, why am I? Okay, first of all, why am I telling you this? They might ask this in KBAT. You might don't care. Okay, you might not care, but it's good for you to think. Okay, this is for our environment. Okay, so when you burn fossil fuel, it's going to create a lot of carbon dioxide. Okay, so now you know COVID-19, we are all trapped inside. Can you see how well the environment is getting to? Because we are not using CO2 anymore, we are not using fuel anymore. Okay, not that much anyway. Nuclear creates zero carbon dioxide. Okay, so imagine if all forms of energy is changed to nuclear, we can at least cut carbon dioxide by half. At least. Okay, so something for us to think about. But how do we handle the waste? That is another problem. That's why you can see one side they fully support nuclear, the other side they despise it. They say, oh no, we should not use nuclear. Okay, that is up to you to think. I think nuclear is the future. It's one of the cleanest form of energy. Okay, anyway, biomass, this is also same as thermal. It's only that we are using different fuel. Okay, just now we use petrol and all. Now we use biomass. So what is biomass? Biomass is basically animal shit. Okay, animal bodies. Okay, carcass. Okay, waste from agriculture, like after you eating durian, the shell you don't want, you throw. Okay, all these we call it biomass. We burn it and then we change it into steam, spin turbine. Can you see? Same concept. Okay, so why is biomass not that common? Because compared to fossil fuel, biomass doesn't contain a lot of energy. Okay, can you imagine burning 1 kilo of 1 kilo of petrol is the same as 20 kilo of biomass. Okay, so I need to store a lot of biomass, like 20 times. This is very stupid to do. Okay, that's why it's not very common. Okay, in India, yes, because India is very big, it has a lot of biomass. But for small countries like Malaysia, we don't have this, so we don't use this. Okay, so yeah, chemical change, energy change, chemical, okay, from the biomass, change to heat, change to kinetic, change to electrical. Okay, simple. And next you have wind. This is very straightforward, straight change from kinetic to electrical. Okay, so basically the kinetic blows the generator and then it spins. Okay, a lot of people ask me, sir, why don't we have wind generator, windmill in Malaysia? Okay, here's the thing. Malaysia doesn't have a lot of wind. Okay, because we're surrounded by islands, we're surrounded by Indonesia, we are at the South China Sea. Okay, that's why you don't get a lot of wind. You might say, sir, very windy here, what? Okay, it's not as easy as you think. Okay, to build a power generator, an electricity generator, it's not easy. You need to plan a lot of things, one of them being money. Okay, imagine I use 60 million to build wind power station. Okay, so and then imagine 1 year. Okay, after generate electricity, I sell the electricity like TNB. They sell it to us, we use electricity. So imagine this windmill 1 year gives you 1 million revenue, means you are earning 1 million. That is a stupid thing to do. Would you use 60 ringgit to earn 1 ringgit? No, that's why we don't build it. Okay, I'm just giving a rough figure for you to understand lah. That's why we don't build this here. Okay, we would rather spend the money on building more factories to extract petrol from the ground. Okay, that's why you see some countries they don't do some power generation. Would you do geothermal here? No, because we don't have volcanoes here, we don't have hot spring here. Yeah, maybe 1 or 2, but we don't do that because it's not very efficient. Okay, it's very wasting money. Okay, and of course solar. This is very straightforward. Solar change to electrical. Okay, a lot of students ask me this as well. Sir, why don't we put solar panel everywhere? Solar is free, what? Yes, it's free, but solar panel is not. Okay, let me tell you a little bit. Solar panel number 1 is very expensive. It's made from silicon. Okay, it's like your electrical board in your PC, okay, or in your smartphone. Okay, so it's very expensive. Number 2, it is not very biodegradable. It's not environmental friendly. Okay, and then solar panel is very sensitive. Okay, I have a student who asked me this. Sir, why don't we put millions of solar panel at Sahara Desert? and then we generate electricity from that. Great idea, isn't it? Okay, here's the thing. Deserts have a lot of sandstorm, have a lot of dust. If the dust is covering the solar panel, it's not efficient. It's not going to generate that much of electricity for you. Okay, they are moving towards solar. Okay, because we are actually moving towards nuclear, but since people don't like it, and then now we are doing solar. Okay, I still think nuclear is the way to go. Solar generates too little energy, so nuclear is one of the best way to go. All right, so that's it for this week. Okay, we are only talking about energy generation today. We're not going to talk about, okay, next week we are going to talk about DC and AC. Okay, so never mind, we will go into this next week. Okay, let's look at some exercise. Okay, what is meant by renewable energy source and non-renewable? So what is renewable? Renewable means it will not deplete. Okay, will not deplete. Okay, or you can say it has constant supply. Okay, for non-renewable, okay, it will be depleted, okay, someday. Okay, so group into source. So we will talk about non-renewable. I'll take for you. Okay, natural gas, diesel, nuclear, and coal. Okay, a lot of countries depend on coal. Why? Coal is very cheap. If your country has coal, most likely it has a lot of coal, like China, okay, and Germany. China uses a lot of coal. That's why during winter, the air gets very bad. Okay, we get haze like 2-3 weeks per year from Indonesia. Can you imagine living in haze for 3 months? This is how Beijing is like. During the winter, everyone switch on heater. Every houses needs a lot of electricity, so the coal power plant has to work extra hard. So burning coal creates a lot of sulfur, a lot of dust. That's why in Beijing, if it rains, it's a lot of acid rain, and the air is very dirty. Okay, that's why in Beijing, if you want to go out, you need to wear mask. Confirm, because it's so dusty. Okay, according to experts, living in Beijing throughout your life, your lung cancer risk increased by 10%. Okay, that's why I don't get why are we using this. Okay, why not just use nuclear? Okay, coal is a very bad thing to burn. Okay, the air gets very smelly because of sulfur. Okay, anyway, so sources of energy can be divided into renewable and non-renewable. What's the difference? Okay, so renewable, we can say won't be depleted. Okay, will not be depleted. Okay, of course can be depleted lah. Okay, write it yourself. Okay, one example of renewable, okay, solar. Non-renewable, nuclear. Okay, state one electricity generator that uses renewable. They want the generator. So who uses renewable? Okay, hydroelectric. Non-renewable, nuclear. Okay, nuclear power plant. Okay, say thermal. Okay, so D, solar energy is used in most developing countries. However, Malaysia has some problems to use solar power as alternative. Explain the problems first. Yes, that's what I told you just now. Number one, solar panels. Oh, sorry, not energy. Solar panels are very expensive. Okay, what else? This is a very K-but question actually. Okay, very expensive. Okay, you can even say, actually Malaysia is a very good place to use solar. Okay, but you can say lack of incentives from government. Okay, believe it or not, government plays a very heavy role in energy. Okay, if they give you subsidy, if they give you, okay, like in Norway, okay, this is tell a little bit. Okay, I'm not sure whether you've heard of Tesla. Tesla is an electric car. Okay, it doesn't require any fuel. You just need to charge your car, like your phone. Okay, you come back from work, you charge your car. Okay, in Norway, 100% of cars sold, almost close to 100%, 90 something percent, are all Teslas. They don't use petrol. They sell their petrol to other countries. Okay, why? Because the government encourage you to do so. Buying Tesla in Norway, automatically they give you 20% discount. You know how much is 20%? Imagine you're buying a 100,000 car, there's a 20,000 ringgit discount if it happens in Malaysia. Okay, so not happening here. That's why, because the government didn't encourage us to do so. Okay, advanced countries, they do that all the time. Okay, changing to a newer car. Okay, using a very fuel efficient car, government actually gives you tax rebate. Okay, not Malaysia is not that common. Okay, so lack of incentive from government. What else? You can even say lack of expertise. Okay, my answer might not be the same as the answer schema. This is my answer. Okay, lack of expertise in solar technology. Okay, do you see a lot of solar companies going around? Not in Malaysia. It's not very common. Okay, solar is like the atas thing. Okay, the rich people thing. When you go buy any house and you see, wow, got solar panel, wow, this person very rich. Okay, it's actually not. How can you? This is the mentality we have. Okay, having a solar panel doesn't mean you're rich. It means you care for the environment. Okay, unfortunately, our government doesn't support this lah. Okay, because I don't know, they are too busy doing their own thing. Not they don't care about the environment. Okay, so Malaysia is one of the worst plastic waste producer in the world. Okay, so you think about that. Okay, so E, name the types of generator that match the description. Water turbine rotates dynamo. Okay, dynamo is generator lah. Okay, not the washing powder. Okay, so this is hydroelectric. Okay, steam produced under high pressure rotates steam turbine. So this is thermal. Okay, nuclear. This is nuclear lah. Nuclear generator. Gas rotates turbine. So you have gas. Gas rotates turbine. Gas. Okay. You can say biomass, I guess. Okay. This is not very clear. Gas. Let me check. Just a moment. Anything we're using gas. Okay. All of them is steam. Okay. Steam. Okay. So it's a bit unclear. The question is a bit unclear. Okay. So number 3, generate electricity. What should be used by Zai to produce electric current? Okay, so move the copper, okay, near the magnet. Okay, like I said, one stays still, one moves. Okay, you create electricity. Kamal and his group members have built a simple generator to complete project-based learning. The diagram below shows a design that can turn on LED light bulb using magnet and copper wire. Okay, so complete the energy change. So I'm using kinetic. Okay, because I'm moving. Okay, I change it to electrical. Okay, explain how the LED can light up. Okay, so what can you do? Okay, you can, not too sure what is this. Okay, you can turn the magnet. Okay, you can rotate the magnet. Okay, rotate the magnet. I don't think you can rotate the wire here. Okay, so this is a very weird model. Okay, so rotate the magnet. Okay, so, and then the generator. Okay, generator will generate electricity. Okay, LED will light up. Okay, number 3, suggest 2 ways to enable to light up brighter. Okay, you can rotate the magnet faster. Okay, I'll talk about this because, okay, common sense, the more kinetic I use, the more electrical energy is produced. So brighter lah, of course. Okay, rotate the magnet faster. Or you can say increase number of coils or turns of copper coil. Okay, what does it mean? Means a coil more times. Instead of 200, I use 400. Okay, I can create more electricity. Okay, so figure below shows tree arrangement, PQR, moving or stationary magnet. Okay, so this one, coil doesn't move, magnet moves. This one, coil moves, magnet doesn't move. This one, both doesn't move. Of course, this is not going to create anything. These two are going to create electricity. In which arrangement does the LED light up? Okay, P and Q. Okay, so I explain why. Okay, so there is movement, okay, in P and Q. Okay, kinetic energy is converted to electrical. Okay, as for R, okay, there is no movement. Okay, so no kinetic convert to electrical. So 3 marks here is to give 3 points. In which arrangement does the LED not light up? Oh, so I don't think you need to explain R here. Okay, R, you move it to here. Okay, so R, because no movement, okay, of magnet, okay, or what is that, the coil. Okay, so no kinetic convert to electrical. Okay, so what is produced in the coil? Don't say electricity, okay, you can say electric current. Okay, so name a device, power station, that applies a similar concept. So which part of generator use the same thing? The power station, you can say the dynamo, okay, or the generator. Okay, same thing. So number 5, Hakimi and his friend built a simple generator that can light up the LED using magnets and wire coil. Okay, so I rotate this thing. Okay, so I rotate these two are the conductor, the coil, and then the magnet doesn't move. Okay, how is the current induced in the generator? So I can say rotate the wire coil. Okay, is the current induced when the wire coil is 90? Oh, you know what? I'm not going to talk about this. Okay, the answer is no. Okay, because the magnetic field of current of the wire coil doesn't cut the magnetic field. Not going to talk about this. This is not your syllabus. Okay, this is a generator. Okay, so I'm heating. This is a thermal. I'm heating water, turns into steam, and then it spins the turbine. State the type of generator. Okay, this is thermal. Okay, so chemical energy changing into heat, change to kinetic. Okay, then electric. This generator use fuel as its energy source. State 3 fuel that I use. Okay, you can use biomass. Okay, you can use coal. You can use petroleum. Okay, state 2 other generators that use following fuel as the energy source. So natural gas, you can say state 2 other generators. Okay, I think thermal generator. Okay, thermal, both I think use thermal because they are fuel. Okay, and then what are the disadvantage of generator uses fuel? So what is the disadvantage? Okay, it creates, okay, pollutants. Okay, or you can say air pollution. Okay, so again, power station X. Okay, this is also thermal. Okay, based on the above diagram, state the change of energy. Okay, so you start from chemical, change it to heat, you're heating water, and then water moves. As steam, you have kinetic, and then it change to electrical. Okay, state the disadvantage of using the type of power station compared to hydroelectric. Okay, so you can say it is non-renewable. Okay, and then you can say it creates pollutions. Suggest another energy source that can be used to generate electricity in areas near the ocean. Okay, you can use wave. Explain your answer. Okay, wave or tidal, same thing. Okay, wave or tidal. Explain your answer. Okay, so the wave can be used to spin the turbine. Okay, so if your country has a lot of wave, of course you're going to use this. It's free. Okay, it's free. Just to build generator, let the thing rotate. Okay, so again, electrical generator. What's the power station? This is nuclear. State the energy use. Okay, from nuclear energy. Okay, oh, they just want the energy, so nuclear energy. Or you can say heat energy. Okay, basically it creates heat. Write the energy change. Okay, from nuclear. Okay, to heat, to kinetic, to electrical. Name another electric energy who has the same energy change. Okay, thermal. Thermal is the same thing. It's just we're using different fuel. One I use nuclear fuel, one I use fossil fuel. Okay, suggest a suitable type of generator to small town and remote village. Okay, small town and remote village. Small town, you can use solar. Okay, why solar? Because solar, you can say it is sufficient, okay, to sustain small towns. Okay, solar doesn't create a lot of energy, that's why for small town it's just nice. Okay, so why? Because it has low maintenance. Okay, you don't need to always go to the power plant and maintain this spoil, that spoil. Power plant, solar power plant is just solar panel. Spoil, you just change it. It's not like nuclear, you have a lot of things that can go wrong. Okay, it's very complicated. That's why nuclear power plant is very expensive to build, because not only do you build the machine, you need people to maintain the machine. You need a lot of engineers to work the nuclear power plant, so it's not easy. Okay, so I think I'm gonna stop here. Okay, it's getting too long. Okay, so finish this yourself. Okay, you have a lot of time at home. Okay, I hope you are staying updated with our lessons. Okay, just because you're on holiday doesn't mean you don't learn. Okay, use the time. I'm not asking for hours per day. Okay, you can just spend 30 minutes per day reading through, do some exercise. Okay, that will do. All right, so that's it from me this week. Okay, I hope you learned something this week. Okay, and next week we will continue with electricity. Okay, so good time for you to refresh a little bit, going back to your Form 2 notes if you have them. Okay, go back and refresh a little bit on that. Okay, it will help if next week we are talking about AC and DC. Okay, I hope you still remember what is your current, what is your voltage, and what is your resistance. Our Ohm's law, V equals to IR. Okay, so thank you again. I will see you again next week. Okay, study. Okay, stay updated with our lessons. Okay, till then, see you. Bye bye.